Welcome back. I'm so glad you're here. Today, I'm going to show you how to create a Sudoku solver in Python using backtracking so that you can instantly solve any Sudoku puzzle. Let's get started. For this Sudoku solver, I first created a list of lists that stores the integers. So for the Sudoku puzzle, if there's a blank space, I have a 0. And if there's a number 1 through 9, I have it in there. So before we start actually coding, let's see how this works. In this Sudoku solver, we'll use the backtracking algorithm. It goes in order, then if it runs out, it backtracks. So what exactly does this mean? Well, it's good to see in action. So we have a 0 here, so it's going to start by saying, can I place a 1 here? Yes, it can. Then it looks to the next 0. Can I place a 1 here? No, I can't, because I have a 1 in the same row. Can I place a 2 here? Yes, I can. For the next 0, can I place a 1? No. Can I place a 2? No. 3, no. 4, no. 5, no. 6? Yes, I can. And the next one, I can't place 1 through 6, but I can place a 7. And the next 0, I can't place a 1 through 7, but I can place an 8. And then here's where the backtracking comes into play for the first time. Because 1 through 8 are already in the row, but there's a 9 in the column, I can't place anything here. So what do? I backtrack to this 8. And now I replace this 8 with a 9. Then here I can place an 8. So if there's no more valid solution, it backtracks and replaces the previous values with a 0 or a blank space until it gets the solution. And this is much faster than going through the board every single time to see, can I place only that number there? This is very efficient, and as a result, you'll be able to solve this board in less than 1 second. So now that we know the basics, let's start with actually coding this. Well, first let's create a function that prints the board. So I'll create a for loop, and I'll say for row and range the length of the board, and up above I previously defined the length of the board to be 9, so I can just put length board here because we're going to use the length of the board multiple times, so therefore I created a variable. Makes it much easier. And I'll say if row mod 3, that means is it divisible by 3? If this is equal to 0, so if it's true, and the current row is not 0, I want to print a blank line because this means I'm in between boxes in terms of rows. We'll see this later. And then for the columns, I want to do a very similar thing. And this time, I'll have a line going up and down. And if it's the last column, I want to print a new line. So I'll do that. And then for every space, I want to enter the value. And then I want to have a space after it. But if it's the last column, 8 here, because remember indexing in Python starts at 0, so it goes 0 through 8, not 1 through 9. So if it's the last one, I don't want to print a space at the end, so that's why I have if call not equal to 8, print the value in a space. Otherwise, just print the value and then have a new line, because I don't want a new line if it's not the end. That's why I have comma end equals and then nothing, because the traditional ending is a new line character, but for the last one I don't want that. And this for loop of columns is inside the row for loop. Because of this, you can get to every row and column. And now if I run this, this should print the board, and it does. This prints our original board successfully with lines in between each box. So this works. So now we can start with our next function. If you remember in the example, we want to find the next empty space, so we're going to create a function for this here. So I'll create two nested for loops like before, and then if the board at location row column is equal to 0, this means we have an empty space. Therefore, I want to return the row and column, and I'll do this here as a tuple, so it will pass two values at once. Otherwise, if this goes through the entire function and doesn't find a 0, I want to return none, so I'll do that here. So this is a nice simple function that we'll be able to use later. I'm then going to create a function called value placement that sees if the given number can be placed there. So at the beginning, we wanted to see if a 1 could be placed in the first row, first column. So this will return true if it can place it there and false if it cannot. And valid placement has the board, has the number, which will be a number between 1 and 9 in position as a tuple. The tuple has the row and column position, so I want to get that. So I'll say row position comma call position equals the position. So this creates two variables that we'll use. The first thing I want to check is if it's valid for the current row. So I'll loop through the columns to see if that number is anywhere in the row, and if it's anywhere in the row except the current position. So I'll say and call position does not equal column. Therefore, there must be two values of the same number in the given row. Then this will return false because this is not a valid solution. And I want to do the same exact thing for the columns, so I put that here as well. Now that we check to see if it's valid for the rows and columns, we want to see if it's valid for the given box, because you can only have 1 through 9 once in the given 3x3 space. So we want to see where the box starts, so I'll create a variable start box x, and I'll set this equal to row position divided by 3 and rounding down to an integer, so it's 2 divided by signs here. Therefore, it won't return a decimal number, it will just cut that off. And then I want to multiply it by 3 because each box has a length of 3. And I'll do the same exact thing for the column. Then I'll create two nested for loops like before for start box x and start box y. And the range is going to start where the box is located and go up and to, but not including start box plus 3. So that's start box x plus 1, and start box x plus 2. Same thing for the y's. So if the value in the specific row and column is equal to the number, but the current position is not in the row column, that means it's also located somewhere else. And you can't have two numbers that are the same in the same box. So I'll return false. Now that we know it can go in the row, in the column, and in the box, we know it is currently valid, so we'll return true. So that was our biggest function, and now we'll actually solve it using backtracking. The first thing we want to do is find the next empty space in the board, and we'll pass in the board, and we created this function, and this will give us a tuple, but if there's no more spaces, it's going to return none. So if not find, this means it returns none. Then we know we have successfully solved it, so we want to return true. And then otherwise, we know that find is a tuple, so we'll create two variables, row and call, and get the values from find. if we're still solving the board and we want to pass in a number 1 through 10 into valid placement, and we'll pass in the board, the number, and the placement as a row and column. And then if this is valid, that means we can set the location temporarily to the number to see if this in fact works. And here's where backtracking comes in. So we're gonna recursively call this function. So what is recursion? It calls the function inside the function itself. So we're calling solve inside itself right here. And if this is true, we're going to return true. So we'll successfully break out of this. Otherwise, there's no more solutions, so we're going to backtrack and set the board at the location row column back equal to 0. And in the case we don't solve it, we're going to return false. So this successfully completes backtracking because we see if we can put the number there, then we put the number and the location, then we call it again to find the next empty space and do this until there's no more locations. And in the case it can't put a number there, it returns false, so it backtracks and puts board row column equal to 0, and will loop through everything until everything is true. So now that we have this complete, we want to actually solve it. So I'll just call the function solve and pass in board, and then I want to print some new lines so that we have a space in between the original board and then solve board that I'm going to print here. In case our original board is not valid for Sudoku, we want to print that it's an invalid board. So I'll just put if next empty space does not equal to none, that means for some reason there's an empty space, I'm going to print invalid board. And you should never see invalid board if you have valid board. That's just text there in case there's an error in your original board. And I see when I ran this that the if solve board should be tabbed in because we should only solve it if there's a valid placement. And now I'll run it and we see it successfully solves our board, and you can input any possible board at the top and it will solve it almost instantly. And there you have it. You can solve any Sudoku board in less than 1 second. Thank you so much for watching. Make sure to follow along with this video series by subscribing and hitting the notification bell, or by clicking on the next video so that you can expand your knowledge about Python. And as always, I can't wait to see you next time.